Hello everyone. This is K-Size China. Today, we bring you an IoT data transmission product based on satellite communication, the Kestrel 400. This product is suitable for outdoor scenarios, has an IP67 protection rating, and can be used with a solar panel. Next, we will give you a detailed introduction to this product in 3 parts: assembly and wiring, device configuration, and function testing. Part 1. Assembly and wiring. After receiving the product, first check whether the packaging is intact. If everything is correct, open the package. Inside, you will find an integrated satellite communication terminal, a connection harness, and a 400 MHz whip antenna. Now, install the whip antenna onto the SMA antenna interface of the terminal. Tighten it firmly to ensure good contact and secure installation. Next, connect the harness to the terminal's wiring terminal, and then tighten the nuts to secure the connection. The cable definitions are as follows. Red, power positive, supply voltage range 8 to 36 volts DC. Black, power negative. Green, 485A. Yellow, 485B. That concludes the assembly and wiring part. Part 2. Device configuration. First, we need to prepare the sensors. The first is our company's ultrasonic level sensor, KUS550. The second is the satellite communication terminal. The third is an RS485 USB module, which needs to be connected to a computer or host system. We also need a serial port debugging assistant and terminal debugging software, which will be installed on the computer. The wiring method is shown in the diagram. After completing the wiring according to the diagram, we need to use a serial tool to check whether the serial connection between the satellite terminal and the sensor is functioning properly. First, open the serial tool SSCOM and select the serial port window connected to the terminal and the sensor. With the port number COM4, set the baud rate to 115,200, the default baud rate of the satellite terminal. Then click Open Serial Port. Next, enter an ATMAND, press Enter, and send it. If the device replies OK, it indicates that the satellite terminal's serial connection is currently working properly. Now we switch the display mode to hex display and hex send, and enable Modbus CRC check. The sensor's default baud rate is 19,200. But the satellite terminal does not support 19,200. So, we have changed the sensor's baud rate to 9,600. Now, using the 9,600 baud rate, send this Modbus command, including CRC check. After clicking Send, you can see the sensor reply with the data 0B4A. Among this, OB4A is the current distance value measured by the sensor, which indicates that the sensor's serial communication is normal. Next, close the serial port in SSCOM and open the satellite terminal debugging software. Click Update COM ports. Select the port where the terminal is located, COM4, and keep the baud rate at 115,200. Then click Open Serial Port, and then click Query Configuration. Sometimes you may need to click it several times. When execution successful is displayed, it indicates that the parameters have been read successfully. Next, we add a new channel. Adding a new channel is to configure the sensor for the satellite terminal. Click Add Channel to start configuring the sensor for the satellite terminal. Select channel number 1. The sensor slave address is 1. Select function code 03. Enter the register address 0 by 0101. The register address needs to be determined according to the sensor protocol manual. Taking the KUS 550 series ultrasonic level meter as an example, the distance value is stored in the 0 by 0101 register. Register quantity 1. CRC option. Select 0. Low byte first. The collection period from 0 o'clock on day 1 to 0 o'clock on day 2 represents a full day continuous collection, which is the default setting. Click Enable Modbus. And then click Configure Acquisition command. Click Advanced Configuration and change the satellite terminal's baud rate to 9600, matching the sensor. Click Set. Then check Change Baud Rate to 9600 and write to Configuration. This will write all the previously changed baud rate and serial port parameters into the satellite terminal. Close the serial port. Since the device needs to be restarted after changing the baud rate, send a restart command to the terminal via SSCOM. At a baud rate of 115,200, enter the 8 command, CRST. After clicking Send, the terminal will automatically switch to the 9600 baud rate we configured. At this point, change SSC OM's baud rate to 9600 and send another @ command. If OK is received, it indicates that the terminal has successfully switched to the new baud rate. Clear the window. Wait for a moment. Observe whether the satellite terminal is communicating with the sensor. If communication occurs, a series of commands will appear. Wait briefly and make sure to switch the display to HEX. Now, we can see that the terminal and sensor are communicating with each other. 0, 10, 30101001 D436. Modbus query command sent by the terminal. 0103020B47 FF46 sensor reply, including measured value. At this point, the sensor and satellite terminal have successfully established communication. Part 2 ends here. Part 3. Device testing. Step 1. Place the configured device outdoors and power it on. Then record the distance from the sensor to the target. Step 2. Observe the indicator lights on the terminal. The indicator status and corresponding descriptions are as follows. Step 3. Open the testing website and check whether any data has been received. Press Enter to proceed. We then enter the satellite data query website. Click on the device SN field and enter our device SN13502. After press. You can view all service frame data under device 13502. The last 8 digits are the data we need. The last 4 digits represent the sensor's measured value. And the digits from the 8th to the 4th from the end represent the sensor's serial number. Then verify whether the measured data is correct. If the data is correct, the device is functioning properly. In this test, the testing platform can only display the sensor's raw data, hexadecimal. If customers need to convert the data into intuitive physical parameters, they must do so on their own platform, or request us to customize a platform. We will push this raw data string to the customer's server address or designated platform for their own data parsing. End of Part 3.